Hi everyone, happy STEM Day. I'm Miss Monteith. I am the high school chemistry teacher here at Pinecrest, and I have a couple of demonstrations that I want to show you guys of how awesome science is. Now, of course, whenever we do science, we have to make sure that we have proper lab safety protocols in place. So, for example, hair needs to be tied back, especially whenever dealing with chemicals or flames, and you always got to make sure that you wear safety goggles as well. Now, the first thing that I want to show you guys it's just a neat little demonstration. So here I just have a cup of water. It's just simple water, and I'm gonna add some food coloring. So today I chose blue because I like the color blue. So I'm gonna put that in there, swirl it around a little bit so that it spreads. Now what I'm gonna do is add just some simple oil, and you can do this at home if you would like. So I'm just gonna pour some oil into my beaker. So we're going to pour some in. And the first thing that you probably are noticing is that there is a separation of the layers, right? So we have the water below, that's blue, and on top we have the yellow oil. And this is because of density differences. So water is more dense than oil, which is why it sinks. And so oil is less dense, so it will always float on top. And the next thing I'm going to do is I have some antacid here. This is for if you ever have an upset stomach or something. And I'm just going to drop one of these into my beaker. And then we'll just watch what happens. So we can see that it is starting to fizz up a ton. Antacids are effervescent, meaning that they bubble up in contact with water. And so we can see it bubbled up in the water, and it's creating all these cool looking bubbles in our oil. So we're just gonna let that run for a moment. Oh yeah, this thing's pretty active, huh? Pretty cool. So I'll move it up a little bit closer. We can see all these colored bubbles going on from that blue water. And this is just gonna keep reacting until the antacid runs out. The next experiment I want to show you guys is definitely a little more, or a lot more dangerous actually. So what I have here is the metal called sodium. And if you notice, it is packed in a container and also shipped in cat litter, because if it comes into contact with water, it's highly explosive. So definitely not something that you want to play around with. It's very dangerous to work with. Now, this is sodium, and I know what some of you are thinking, don't we eat sodium in our food? That's not the same thing. So the sodium in our food is actually sodium chloride, table salt, which is made of sodium, but is also bonded with something called chlorine. So when those are bonded, it does make a nice stable compound that will not explode. But of course here I have pure sodium, which is very explosive. Now here I have, I'll move my camera here a little bit, a flask full of water. And I'm going to add a little something special to it. And this is called phenolphthalein. And I'll tell you guys about it in just a moment. But I'm going to pour just a little bit in there. Just a little bit. I swirl it around. And you can see it's clear. So the water's still clear. Now, of course, I am not going to throw the sodium directly into this because that is terrifying. But I'm going to add some more oil in here. So I'm going to pour some oil. All right, and then of course, as we saw with the previous experiment, the oil does flow on top of the water because it is less dense. So let's go ahead and watch what happens when we put some sodium. Oh, there's like a little oil bubble at the bottom. It's kind of funny looking. But anyway, what happens when we place sodium in this solution that I've made here? So sodium is a metal, and it is actually very soft. It's like, you could cut it like butter, really. It's super soft. To give you a good look at it, try to get it in the camera. This is what it looks like. So it's a metal, it's shiny, but of course, like mentioned, it is highly reactive in water. Like literally will explode. So I'm going to drop some in. and we'll see what happens. All right, what are some things we're noticing? Okay, so your first thought might be, what the heck, is that pink? Yes, so if you remember, the phenolphthalein that I put in is actually an indicator. So what an indicator means is that it tells you if you're dealing with an acid or a base. When it comes into contact with a base, it turns pink. And so when sodium interacts with the water a little bit, I'll shake it down a little bit more. We'll watch it. Okay, so it interacts with the water. Now we're not completely throwing it in the water because we don't want to have an explosion, but it does interact with the water, creating bubbles, and it then turns the water pink because it's turning the water more basic. So that will just keep bouncing up and down. This is a really safe way of not exactly playing with sodium, but dealing with sodium because, like mentioned, it is very volatile and it will explode on contact with water. And to be honest, it's terrifying. So, but that's pretty cool, right? So we got our little sodium piece in there. It's floating at the bottom again. Let's see if it'll settle back down. Kind of gotta shake it down. Come on. It's not in the mood to sink, I guess. It's just not feeling it. So it keeps buoyant in the oil. It doesn't actually go into the water. It just gently touches it and then it bounces up. So there you go, sodium in water. It's pretty cool. And like mentioned, I have this phenolphthalein, which is why it turned pink, because it's a basic solution. So the next experiment I want to show you guys deals with this. This is a portable Bunsen burner, or you kind of think of it like a mini flamethrower in a way. So what I have here is butane inside of this canister here, and there is a flame that will come out. So I'll show you guys. Got a nice big flame going. So we're gonna do a couple things with that. This is actually one of my favorite experiments to do with my chemistry kids, and I hope it'll show up well on the video. But what I have here are some compounds. So I have a couple, and I'll talk about each one, and I'm going to show you guys what they look like when they are set on fire. And I'm going to actually turn off the light here, so hopefully we can see it a little bit better. So the first one I'm going to do is NaCl, and that is sodium chloride. So this is sodium bonded with chlorine, and it's basically just, it's literally salt water. That's what this is. So it's salty water. So we're gonna go ahead and get this lit. All right, so we're gonna stick this in the flame and look at the color. All right, we can see it glows a very, very, very bright orange, like super bright. So that's sodium chloride. When it is burned, it creates a very bright yellow orange flame. Okay, let's try another one. I'm gonna turn this off. Okay, so let's try strontium chloride. So this is a mixture or a compound of strontium and chlorine. So we're gonna dip that in the solution here. Gonna turn this on once again. All right, got a nice big flame here. And this one does take a few moments to do its reaction, so we gotta give it a little second. There we go. All right, strontium chloride, as you can see, glows red. Isn't that pretty? Oh, and look, I melted my Q-tip a little bit. But it is a red flame that's produced. Isn't that cool? Copper chloride, it also has copper in it, but bonded with chlorine. So we're gonna dip that in, and this one you should be able to see really well. Okay, here we go. Gotta give it a second to think. Gotta think about it. There we go. That one is very, very green, and I hope you guys are able to see that. Definitely have some yellow and orange like we saw with the copper sulfate, because copper is very yellowy green, but this one is a very strong green. So if you're thinking this is cool, when you get to chemistry, you'll actually get to do this yourself. Science is so cool.